Let us look at proposition number 1 of works of Archimedes, specifically from on the conoids and spheroids. Before we actually look at the proposition, let's look at a lemma. So the lemma says, if in an ascending arithmetic progression consisting of the magnitudes a1, a2, a3, an minus 2, an minus 1, an, the common difference be equal to the least term, then n times an is less than 2 times the sum of all the terms. Again, n times an is greater than 2 times the sum of all the terms except the last term. So, given an arithmetic progression a1 to an with common difference equal to a1, then n times an is less than 2 times the sum of the terms. And n times an is greater than 2 times the sum of all the terms except an. Now, the proof of this is not given here. It is given in another book, that is on spirals, as a proposition. So we will look at it when we start off with that book. Okay, so now let's come to the proposition. The proposition says, if a1, b1, c1 k1 and a2, b2, c2 k2 be two series of magnitudes such that a1 is to b1 is equal to a2 is to b2, b1 is to c1 is equal to b2 is to c2, and so on. And if a3, b3, c3 k3 and a4, b4, c4 k4 be two other series of magnitudes such that a1 is to a3 is equal to a2 is to a4 and b1 is to b3 is equal to b2 is to b4, then sum of all the magnitudes a1 to k1 is to sum of all the terms of a3 to k3 is equal to the sum of all the terms of a2 to k2 is to the sum of all the terms a4 to k4. So let's look at the proof of this. Now, we are given that a1 is to a3. Where is that? a1 is to a3 is equal to a2 is to a4. So we invert it. We do invertendo. Or rather, take the reciprocal on both the sides. So we end up with a3 is to a1 is equal to a4 is to a2. Now we are given that a1 is to b1 is equal to a2 is to b2. And we are also given that b1 is to b3 is equal to b2 is to b4. So we have these three proportionalities. We can combine them into a single statement. a3 is to a1 is to b1 is to b3 is equal to a4 is to a2 is to b2 is to b4. So that means x equally, we can say a3 is to b3 is equal to a4 is to b4. And similarly, we can show that b3 is to c3 is equal to b4 is to c4 and so on. a1 is to b1 is to c1 equal to a2 is to b2 is to c2 and so on. So which means we can write it as a1 is to a2 is equal to b1 is to b2 is equal to c1 is to c2 and so on. Now a1 is to a2 is equal to the sum of the antecedents is to the sum of the consequents. So we end up with A1 is to A2 is equal to A1 plus B1 plus C1 dot 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 K1 is to A2 plus B2 plus C2 dot 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 K2. Now, A1 plus B1 plus C1 plus dot 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 K1 is to A1 is equal to A2 plus B2 plus C2 plus dot 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 K2 is to A2. Similarly, we end up with A3 is to A3 plus B3 plus C3 plus dot 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 K3 is equal to A4 is to A4 plus B4 plus C4 plus dot 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 K4. Remember, we already know that A1 is to A3 is equal to A2 is to A4. So here we have A1, here we have A3, A2, A4. So that means A1 plus B1 plus C1 plus dot 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 K1 is to A3 plus B3 plus C3 plus dot 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 K3 is equal to A2 plus B2 plus C2 plus dot 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 K2 is to A4 plus B4 plus C4 plus dot 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 K4, which is what we had to prove. Now, there is a corollary to this proposition. It says, if we remove one term from the end of the second and the fourth, then the proportionality doesn't change. So, which means A1 plus B1 plus C1 plus dot 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 K1 is to A3 plus B3 plus C3 plus dot 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 J3. J3 is the previous term of K3 is equal to A2 plus B2 plus C2 plus dot 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 K2 is to A4 plus B4 plus C4 plus dot 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 J4, where J3 and J4 precedes K3 and K4. That is proposition number 1 of on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.